Here we go. Okay, so for those of you who were at wrestling and are listening in, here's our notes from 8.3. You'll want to pause the video probably at this point and copy down what I have written up here so far. But we're graphing things. We're graphing fractions. And today's section is about the denominator being linear. So it kind of talks about that in the first section. And you'll see, based on the transformation section, there might be something in the numerator, but it'll just be a constant. It won't be anything linear in the numerator, and you may have a constant added at the end of your k. So let's go ahead and jump right into some graphing. We're going to have some asymptotes in this section. We'll have to worry about domain and range as well. Let's start with the graph of f of x equals 5 over x. So you notice the denominator is linear. There is a coefficient in the numerator, or there's a constant in the numerator. We're going to care about the domain, the range. There's going to be a horizontal asymptote and a vertical asymptote in these problems. And you see I mention those in the brackets here in the transformations section. Scroll up a little bit. Okay, let's jump right into making a table of values, since we at this point don't really know what to expect. Actually, we can consider the domain. We can figure out the domain. The domain is our restriction on x. We have a fraction. We know that a fraction is undefined when your denominator equals 0. And your denominator in this case will equal 0 if x is 0. So your domain is going to be restricted to when x cannot equal 0. I'm going to use the textbook version of, or way to give domains and range, which is what I don't typically use. So we can just say that x cannot equal 0. So in these brackets I just put x and then a vertical bar, x is not equal 0, so x can really be anything except for 0. And so when I make my table of values, I'm going to avoid using 0, obviously, but I might surround 0. So I'm going to I'll pick two numbers on each side of 0. I'll go -2, -1, and then I'll go 1 and 2. We're probably going to get fractions. That's okay. When I plug in -2, I get 5 over -2, so -5 halves, or -2.5 if I want a decimal. When I plug in -1, 5 over -1 is -5. When I plug in 1, 5 over 1 is 5. And then 5 over 2 gets us 2.5. By picking numbers close to that domain restriction, that's going to ensure that I don't get too huge of numbers to graph, or hopefully they won't be too large of numbers. If I get very far away from there, they start to get a little more troublesome. I guess that's probably true as I get closer and closer to 0 than it is farther away. And I actually do know that I have a vertical asymptote at this point. It talks about that x up here, down here. Yeah, the h here is 0. And so that's going to be my vertical asymptote. My vertical asymptote is the line x equals that h. In this case, it's 0. So we couldn't hit 0, but we can hit anything else. And so if I start to graph this, we see that there's the vertical asymptote at x equals 0. And when I'm on the left side of that asymptote, my graph is down here, and it's actually looking like this. I'm approaching that asymptote. But when I look at the right side, we're kind of in a different quadrant of the graph. This kind of picture is what we call a hyperbola. So we've had a parabola before. This is a hyperbola. And so we would call each of those branches of the hyperbola. Now, if we were to graph this on the calculator or pick more and more points, we realize that as we travel to the right on the right branch or travel to the left on the left branch, it's getting closer and closer to 0, but it actually won't be 0. So we do have a horizontal asymptote as well at y, or in this case we're using f of x, at f of x equals 0. So there's an asymptote here too, which does truly split the graph into quadrants. The two branches will be in opposite quadrants. So my range then, my y or my f of x can be everything except for that value, except for the 0. So if I use this bracket notation, I'll say f of x, but f of x cannot be 0. So now let's take a look at a problem with more numbers to deal with. Let's go with f of x is equal to -1 over x minus 2 plus 4. We'll have a domain, a range, and then we'll have both asymptotes as well. So where are we going to be undefined in this case? Look at the denominator. The denominator of a fraction will be undefined when x is equal to 2, because we would take that entire denominator, x minus 2, set it equal to 0. We know that it's undefined when x minus 2 is equal to 0, so if we solve that for x, we see that it's undefined when x is 2. So for our domain, we say that x cannot be 2. So that means that our vertical asymptote is at x equals 2. And when I make a table of values, I'm going to surround the 2. So 4 and 3, I start on the upper side, I guess, and 1 and 0. Okay, I kind of leave that little blank in the middle. Those are the two branches of the hyperbola. And I see that if I look at my rules from above, my horizontal asymptote is at y, or f of x is equal to k, and my k in this problem is 4. Everything shifted up 4. So my horizontal asymptote is f of x, or y, you can use y, I'm okay with that, is equal to 4. And so my range is that f of x cannot be 4. But other than 4, it's all real numbers. So let's plug numbers in. And really, now that we're getting more complex, I'm okay with us pulling out the graphing calculator and using the table feature. So I'll model that or give you an example. So if I type this in, -1 divided by, I better put parentheses around my denominator. That way my calculator understands x minus 2 is the denominator. Add 4. So I've got it typed in my y equals, if I go to my table, I can jump to 4. I decided to use 4. That's 3.5. Notice the error at 2. We know we have an error there. You can't see clearly. It's not a real big picture. But at 4 I get 3.5. At 3 I get 3. At 1 I get 5. And at 0 I get 4.5. And you'll see those numbers, 3, 3.5, 4.5, 5, they're surrounding 4. They're getting close, but they're not quite hitting 4. So if I graph this, so at x equals 2, I've got this asymptote. At y equals 4, I have a horizontal asymptote. And so that splits my graph into quadrants. The quadrants don't necessarily agree with the xy axis, but they make their own quadrants. There's an upper right-hand corner, an upper left-hand corner, a lower left, a lower right. The two branches of my hyperbola will be in 2 of those 4 quadrants. And they'll be opposite corners. Let's find out which ones. So 4, 3.5. So here I'm in the lower right. And at 3, I'm up at 3. So I've only got 2 points in that quadrant, but I know that I'm bound to the quadrant. I can't touch the asymptotes. So I'm going to curve, hit those 2 points, but otherwise stay in that quadrant following the 2 asymptotes out. So there's one portion of my hyperbola, the right portion. And at the left portion, I'm at 1, 5. And then I'm at 0, 4.5. So we're going to hit those 2 points and curve, otherwise follow our asymptotes. And you'll see we're in the opposite corner or opposite quadrant of our asymptotes. So that's what your assignment is going to be doing. It doesn't really get trickier than that, but you're going to identify the H's and K's, and that will help you with the asymptotes, domain, and range. I'm okay with you using a graphing calculator to find order pairs, or you can plug them in by hand. And if I've got the graphing calculator here, I already checked it for the table. I just as well check my graph and verify that it looks the same. And yeah, I see it looks pretty similar. The zoom of the window is a little bit different than mine, so it looks a little bit different than mine, but we get the overall picture. We see there's a horizontal and vertical asymptote going on there. All right, and for those of you that are not here, that are watching via video, I am giving out a calendar today, but you won't have the calendar if you're not here. So let me write the assignment down up here as well. It is page 549. Number 7 through 10, and 12 through 21 multiples of 3. That will be the assignment. We'll have it due Friday. I know some of you will still be at wrestling on Friday. Friday we will be having a review worksheet. I will post that review worksheet to the S drive. So if you're not here and you want to access it through the S drive, you can do that as well. There will not be a note video tomorrow or on Friday just because there won't be any new material. We will also be reviewing on Monday, so we will quiz on the block day. We'll have short periods on Monday because of the assembly, but we'll have 2 review days prior to this quiz.